Today is section 31-2, right triangle trigonometry, and we're going to take a look at the concept of SOHCAHTOA. So today we're going to state the 6 basic trig ratios, and we're going to evaluate trig ratios of the sides of a right triangle using those 6 basic trig ratios. So in geometry, we gave the names of the sides of a triangle from one of the 2 acute angles of a right triangle. So let's just say hypothetically I wanted to use this angle as my angle, or the angle I'm going to make my references to. That means from this given angle here, this is considered my opposite side, or the opposite leg. And then from this angle, this is considered the adjacent leg, or the adjacent side. My hypotenuse is always the hypotenuse because it's going to be always opposite from the 90 degrees. Now the 2 legs are labeled either adjacent or opposite, like I said, and using these we could actually compute this the 6 different trig ratios, and we're going to see that in the next slide. So let's just say hypothetically I take that same triangle, but I say my opposite leg is 5, my adjacent leg is 12, and my hypotenuse is 13. I can actually compare the different sides to the with the hypotenuse, or even the different sides to each other, to create these different ratios. Like, for example, I can say opposite over hypotenuse, or the adjacent to the hypotenuse, or the opposite to the adjacent. And doing so, you know, my opposite over hypotenuse would be 5 over 13. My adjacent over hypotenuse would be 12 over 13. My opposite to the adjacent would be 5 over 12. And then the hypotenuse to the opposite would be 13 over 5. And then 13 over 12, and last 12 over 5, as we have adjacent to the opposite. Now these different ratios have names. They each have names. So we call this first ratio, the opposite to the hypotenuse, we call that our sine ratio. We call this ratio, the adjacent to the hypotenuse, we call that our cosine ratio. The ratio that's opposite to the adjacent, we call that our tangent ratio. The ratio that's hypotenuse to the opposite, we call that cosecant. We call this ratio secant, and this ratio cotangent. Now one thing to notice here is that, let's look at my sine ratio and my cosecant ratio. Now what's the relationship between 5 over 13 and 13 over 5? Now you probably answered yourself, well, those look like reciprocals, and if you said that, you're actually right. Sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other, and tangent and cotangent are going to be reciprocals of each other. Now in order to make things a little easier, we actually use abbreviations. So we say sine of theta, sine of theta. Instead of writing out sine of theta, we just say sine of theta like this. Now this isn't sin, this isn't cos, this isn't tan, this isn't x, okay? This is cosecant of theta. We read the entire statement together. So cosecant of theta, tangent of theta, secant of theta. And so it's more proper, instead of just saying, yeah, cos theta, you say cosine of theta. That's the proper way of stating these. Now it's imperative that we know these backwards and frontwards. Something that's going to help us memorize this is the mnemonic SOHCAHTOA. And so SOHCAHTOA is actually going to help us memorize our sine ratio, our cosine ratio, and our tangent ratio. So the sine is opposite to the hypotenuse, the cosine ratio is adjacent to the hypotenuse, and the tangent ratio is opposite to the adjacent. Now how do we memorize the reciprocals? It helps to kind of memorize this phrase, S goes to C as C goes with S goes with C, and C goes with S, and it works backwards too. S goes with C, and C goes with S. So that's a way for us to kind of memorize how sine and cosecant, and then cosine and secant are associated with each other. And then with the tangent and 1 over cotangent, those are always going to be associated. But that should be much easier for us to kind of remember. Now the last thing is, there's no such thing as just a sine. It's always sine of an angle. Sine of an angle. Sine of an angle. That angle must be present. If you do not have that angle present, I'm going to shred your logic. So if you just wrote sine equals 1/2, that makes no sense. I will mark you wrong, and I will take points off for that. There always needs to be an angle there abbreviated with it. So let's practice a few of these. Let's find the ratios. So if I say sine of theta, okay, so we're going to find we're going to find this ratio here, find sine of theta. That means it's asking me what's the ratio that represents that. So the ratio, this is going to equal some sort of ratio. We know that sine is so sine of theta is opposite to the hypotenuse. So I can say sine of theta is opposite to the hypotenuse. And so that's the ratio that it's looking for. That's going to be my answer. So the first thing that I did here is I made sure all the sides are present, which they are. Here's all my sides. The second thing is, having SOHCAHTOA maybe written out, or we're just going to use that to understand it. So it says sine, so I know I'm going to use so. And so opposite over hypotenuse, I have that ratio. And then step 3 is going to apply the reciprocals, which we're going to see shortly. Let's say cosine of p. Well, first step, I need to use the Pythagorean theorem, unless you know the Pythagorean triples. In this case, that's going to be 17, which makes it much quicker and easier for us. And so from this angle, trying to find cosine of p, we know it's going to be ca. So step 2, that's adjacent to the hypotenuse. So adjacent to the hypotenuse. And so this right here is going to be my answer. So look at another one. Find cosecant of x. So finding cosecant of x, well, this is 3 times 5, this is 4 times 5, and so this would be 5 times 5, which is going to be 25. And so cosecant, well, I need to think s goes to c, c goes to s. Okay, so this relates to sine. So if I find what my sine is, then I just need to flip it, and I have my reciprocal. So I have all the sides, so, because it's going to be sine, so step 2, SOHCAHTOA. I have sine is opposite to the hypotenuse, so the sine of x is opposite 15 to the hypotenuse 25. I can reduce that. And so now to turn it into the reciprocal, cosecant of x equals 5 over 3. And this is going to be my answer. So next one, find cotangent of 30 degrees. And so my cotangent of 30 degrees, this is going to be a special triangle. And so if I know this is 14, this is going to be t, and this is going to be t root 3. And so cotangent I know relates to tangent, so tangent of 30 degrees, this might help a little bit. Tangent of 30 degrees is opposite over adjacent, because it's TOA. So opposite over adjacent. Well, those cancel out, so I have to flip it, so that means the cotangent of 30 degrees would just equal root 3, which is going to be my answer. Looking at a couple more, if I wanted to find the sine of this, well, sine of theta equals opposite over hypotenuse, so that'll be 19 over 29. For this one here, cosine of a, well, I have to find the hypotenuse, right? So first step, using that Pythagorean theorem. So a squared plus b squared equals, in this case would be c squared. And so c is actually going to be the square root of 173 if I do that. And so finding the cosine of a, that's going to be adjacent over hypotenuse, 173. And so rationalizing it, you're going to get 13 root 173 all over 173. And so that's going to be my answer. And so this concludes our lesson. If you guys have any other questions, please leave them in the comments.